Assalamualaikum and good morning. So we are from Group C. So my name is Muhammad Izzuddinish.
My name is Muhammad Alif Iqbal.
My name is Muhammad Nabil.
My name is Muhammad Zafran.
So today we are going to present about simulating intermediate building blocks of a computer using logic gates in Logisim for 4-bit synchronous counter using D or T flip-flop and 4-bit register with load and clear using D flip-flop with gating logic. Introduction. 4-bit synchronized counter using D or T flip-flop. First one, the 4-bit synchronized counter circuit is designed to count the number of clock pulses in binary form synchronously. In this circuit, all flip-flops share a common clock signal, causing each bit to change simultaneously each time the clock pulse.
For the 4-bit register that has load and clear using D flip-flops with a gating logic, a register is a sequential circuit that stores multiple bits of data by combining flip-flops. And this design is a 4-bit register, therefore it uses 4 flip-flops. And in this design also, it includes a load which selects whether to load new data or retain the old value, and also has clear which resets all bits to 0.
Boolean function for 4-bit synchronized counter using T flip-flop. This 4-bit parallel counter can be built using either T or T type flip-flop. In the version using T flip-flop, each flip-flop will change state, which is toggle, based on the state of the previous flip-flop. The logical relationship can be defined as follows. T0 equals to enable, which means is 1. T1 equals to enable and Q0. T2 equals to enable and Q0 and Q1. T3 equals to enable and Q0 and Q1 and Q2. For a 4-bit synchronized counter using T flip-flop is simpler and more efficient because they naturally toggle when the logical condition is met. However, D flip-flop are more flexible and general purpose, making them suitable for complex systems that need both counting and data storage.
Alright, moving on to simulation design for 4-bit synchronous counter using T flip-flops. In our design, we are using enable input pin, reset input pin, clock, and then T flip-flops, AND gates, and lastly 4 outputs. Alright, and then going to the screenshot of Logisim circuit and explanation of circuit functionality. First, for enable purpose is to start or pause of the counter. And then for reset input pin, it clears all of the output from any current state, such as 1100 back to 0000. And then for clock, it provides a timing pulse for all of the flip-flops, and for case to make a conditional condition either the next flip-flop will toggle or not. And then for the flip-flop, it will store and toggle every binary states on each block clock plus pulse to generate 4-bit count. And then next after that, for output, it will display all of the current 4-bit binary. And then lastly, for AND gate, the purpose of the AND gate is to decide either if the next flip-flop will toggle based on the previous flip-flop. For example, if FF0 and FF1 output are 1, the next flip-flop, which is FF2, will toggle from 0 to 1 or 1 to 0. Moving on to demo instruction. Alright, here I'm going to demonstrate how 4-bit synchronous counter works in Logisim. So first thing first, you want to make sure to enable the auto tick for the clock. And then if you want to start the count, press enable from 0 to 1. As you can see here, all the flip-flops and the counting have started generating the 4-bit binary. And then as you can see here, the output is currently displayed the current value of the 4-bit binary. And if you press again the enable button from 1 to 0, it will basically pause the counter. And then moving on, if we click reset input pin from 0 to 1, it will reset all the flip-flops and the current output from their current state value back to 000. So once all of the numbers counter reach 1, 1, 1, and 1, the counter will reset back to 0, 0, 0, and 0, just like how 4-bit binary works. All right, now we are moving to next question, which is 4-bit register with load and clear.
Okay, so moving on with the Boolean function of 4-bit register with load and clear. For this design, we are using 4 D flip-flops connected in parallel. And for the flip-flops, it's connected. For example, FF0 into Q0, FF1 into Q1, FF2 into Q2, and FF3 into Q3. And each flip-flop's D input is controlled by gating logic that decides whether to load new data from D0, D3, or hold previous output from Q0, Q3. And for the clear input, it overrides both load and clock signals. For example, when the clear is 1, the Q0 until Q3 is forced to 0, which means it resets, and for when clear equals to 0, the normal operation continues, which means it will continue to store memory. And for the Boolean function, after combining all of the process above, you will get Qn next equals to bar clear times with load times Dn plus clear plus bar load times Qn previous. This means that the next output will take into the clear and also the load, which this register has those features.
So go on with simulation design. For 4-bit register with load and clear, we have 4 input of multiplexers, D flip-flop, and 4 output. We also have button load, clock, and clear. Next is screenshot of Logisim circuit and explanation of circuit functionality. D0 to D3 provide the 4-bit data to be stored in the register. The load button control whether the register keep the old data or load new data. Clock will trigger all flip-flop together on each plus to store the selected data. Output Q0 to Q3 display the store 4-bit value from the register. The flip-flop store 1 bit of data from the multiplex. Multiplex select between the old and new value based on the load signal. Clear button is to reset all output to 0.
So for the live demo of the 4-bit register, first we need to enable the clock ticks, and then for the register it basically stores data. So for example, when we turn on the D0 and D2 to the logic 1, and we need to turn on the load because it needs to input the new data, and you can see the output becomes exactly like the input. And when you turn off the load 0 or make it logic 0, if we input a new data, the old data will stay the same. This is the function of the load. And when we hit clear, it will override both the load and the input, and therefore resetting all the output to 0. And the purpose of this multiplexer here is to select between the new data or the old data. And it also takes the logic of the load. And for the flip-flop here, it basically takes the input and stores the data here, and also make it output to the output signal. So now we are moving on to the challenges, application, and summary.
Okay, so for the challenge, for 4-bit synchronized counter using D or T flip-flops. The first one, timing and reset issue. Getting all flip-flops to react to the same clock edge and making reset reliably. Return all bits to 0, 0, 0, 0. Second, enable and testing. Turning the enable logic so counting only happens when intent. Plus debugging the circuit helps understand timing and logic behavior.
And the challenges for the 4-bit register. At first, we had trouble to incorporate load into the circuit and getting the expected result. And because the clear is very simple, we just connect the clear button into the reset input to the flip-flop. And also for the load, we are using gate logic or 2-to-1 multiplexer to select new data or use the current output. And the gate logic that is used is 2 AND logic and 1 OR logic. 2 AND gates and 1 OR gates, which is basically the same with the 2-to-1 multiplexer.
Okay, so next, application and summary. For 4-bit synchronous counter using D or T flip-flops. For the summary, the 4-bit synchronous counter using flip-flop that share the same clock signal to count from 0 to 15 in binary. It demonstrates the principle of sequential logic, showing how enable and reset signal control counting in digital system. And for the application, the 4-bit synchronized counter is used in the processor to count and control the sequence of instruction step during program execution.
And as for the 4-bit register that has load and clear using D flip-flops with gating logic, for the summary, the 4-bit register using D flip-flops with load and clear features demonstrates how sequential circuit can store, hold and reset data in a digital system. And the 4-bit register is store, the hold is for the load and the reset is clear. And as for the application in CPU, 4-bit register works as a temporary data storage. It registers the registers hold operands, intermediate result of calculations, and frequently accessed values. Therefore, this makes the CPU faster because it doesn't need to access from the RAM as it can access from the register. And thank you very much. This has been Group C presenting our assignment. Thank you.